video is about functional groups. This time, instead of using the PowerPoint that comes with the textbook, I decided to just write the information about functional groups so that we can get right to the heart of what you need to do. Functional groups are elements that occur in organic substances that are a special grouping of atoms that always react in a certain way. And there's a chart in your book you will find of the functional groups. So you should locate that chart somewhere in your textbook in the chapter, and you can look at that while you're watching this video. So we're going to be looking at these particular functional groups. It's not particularly difficult. It's just a matter of memorizing, recognizing, and naming those functional groups when you see them. So let's look at some different functional groups. We have already looked at some hydrocarbons in general, and we have also looked at certain things that have been substituted into the chain, like halogens. Those kinds of naming systems with chlorine and fluorine and so forth, we've already discussed. So I'm going to focus on other kinds of groups of atoms that are put into a parent chain and how to name those. So let's look at alcohols. Alcohol is a functional group that is OH. OH comes that is plugged into the parent chain. So for example, if we have CH3, CH, CH2, CH3, and off of CH we have the OH group. We first think of the parent chain, and we also notice that the OH is off carbon number 2. And there are 4 carbons in the chain. So that's like a butanol, if you will, or a butane-ish kind of thing. Notice I said butanol because I knew this is an alcohol, and all alcohols end in OL. This is actually 2-butanol because 2-butanol means that the OH is off the second carbon. It is possible to have the OH on the end, and that would be 1-butanol, but in this case this is 2-butanol. Another example of a halogen that could be part of an alcohol group might be this one. I might add the Cl there so you can see it. So not only do we have the OH, or the alcohol group, but we have this Cl happening. So you know from this section right here, this is a 3-carbon chain. So this is a propanol, and it's a 1-propanol because the OH is off of carbon number 1. But off of carbon number 3 is a chlorine. So this is a 3-chloro CHLOR, yep, dash 1-propanol. So that's an example, 2 examples of substances that are considered alcohols. Again, this is just touching very briefly on the nomenclature of these functional groups. There's so much more about substitution reactions and the way things can combine to form other things that we could get into, but we do not. Another kind of functional group is called an ether. So ethers, maybe make them all plural, alcohols, ethers. It's another group of organic compounds in which oxygen is bonded to carbon. So how would that look? Well, something like that. oxygen bonded to carbon. So we have example CH3O CH3. This would be called dimethyl ether. And just like alcohol ends in OL, ethers end in ether. Another functional group is the amine, or amines group. Amines contain nitrogen atoms bonded to carbon atoms in some sort of a ring or a chain. So let's look at this ammonia derivative, which would be NH2. These are substances that have amino as the beginning word as part of that name. I'm just going to scroll down a minute and then scroll back so we can have a little bit more space in case I need it. So let's look at an example. CH3, CH, CH2, CH3. And off of this one we're going to have NH2. This looks a little bit like the first one we looked at, with alcohol stuck, the OH stuck onto a butane. Here, this is also a butane, so that's the parent name, and it's 2-amino butane, because you'll notice off of carbon number 2, there's an amino stuck, or an amine stuck into that parent chain. So this is 2-amino butane. The next one we're going to look at is an aldehyde. Aldehyde is a carbon with a double bond and a hydrogen at the end. An example and the name would be CH3, CH double bond O. This would be the simplest aldehyde. And you can see that there's 2 carbons in the chain, and this is ethanal. Aldehydes end in al, A-L. That's how you can recognize them. So it's not, ethanol, it's not ethane, this is ethanal. Another example, CH3, CH, CH2, C double bond O, H, and I'm going to stick a Cl here. Again, we're trying to see what happens when we put halogen mixed in with, in this case, an aldehyde, to change the name a bit. So if we look at the name of the parent chain, we have 4 carbons in the chain. So it's like a butane, but it's not butane, it's butanal. So that's the parent name. Notice off of carbon number 1, 2, 3, this is 3-chlorobutanol, and that's an aldehyde. All right, continuing on in our quest to understand functional groups and their names. Ketones. Just like the others, there's a special structure and a special ending that we have to put onto the name of the parent chain. A ketone is a carbon that has a double bond O. It's actually between 2 other groups, so maybe 2 CH3s on either side, unlike an aldehyde, which just ends in hydrogen. Sometimes it's going to be hard to really focus on what's happening, and it's really important to memorize the form of the functional group so you don't get them confused. So here's a ketone. I'll try to make it look like this one so you can see a bit of the difference. CH3, CO, CH2, CH3. Notice how in the ketone, which by the way has ketone in it, and it ends in -one, you'll see in a minute, there is one group here and another group here around the ketone. You notice in an aldehyde, the ending was always this. That was kind of the end of the chain. That's one way you can differentiate between an aldehyde and a ketone. What would the name of this ketone be? Well, notice the double bond O could be in a variety of different places. It could have been at the end, or it could be somewhere in the middle of the chain. We do need a locator number to say where that double bond O is. So this is 2-butanone. Notice -one for ketone. Here's another one, CH3, CH3. This one is 2-propanone. Again, prop because it's 3 carbon chain of carbon 2, and it ends in -one, propanone. Alright, continuing to move on with different functional group names. We're almost done. We have carboxylic acid. You might recognize certain carboxylic acids. Acetic acid happens to be a carboxylic acid because of its structure. Chemists call it acetic acid. Biologists might call it something else. What's the form of that? Well, it's C double bond O, just like the ketone and the aldehyde, but instead of the hydrogen, like an aldehyde, or another group, like the ketone, it has an OH on the end. It's almost like an alcohol and a ketone came together and formed something else. So let's look at an example of a carboxylic acid. It too has a special ending. Let's look at CH3, CH2, CH2, COOH, and off the CH we'll stick a BR for fun. This part right here is the carboxylic acid part. So if we're going to name the parent chain first, we're going to count. There are 1, 2, 3, 4, 5. That's pent, and this is pentanoic. Ethanoic is the carboxylic acid name, and it's pentanoic acid. That would be fine if there was no bromine there, but there is a bromine, and you notice it's off carbon number 1, 2, 3, 4. So this is 4-bromo pentanoic acid. Let's look at this example too of a carboxylic acid. CH3 COOH. This one is ethanoic acid, and enoic and acid come together for the name of the carboxylic acid. And F, of course, means 2, and you can see that there are 2 carbons. But I think I mentioned earlier, biologists would call this ethanoic acid, perhaps. Chemists would call this pardon me, had the OH there, I got excited. C2H3O2. What would we call that? Acetic acid. So, same substance, written differently. why would this matter? Why would a biologist rather see CH3COOH? Because in some ways that helps us put together the structure of the molecule a little bit better than the chemist's acetic acid, the way we would look at it, hydrogen and acetate together. And then finally, last but not least, is an ester. Esters are a special group of compound in which the hydrogen of the hydroxyl group has been replaced by the alkyl group, producing an arrangement that we're going to see here. And I'm going to give you the generic form of it, and that is C double bond O, O. So the last groupings have double bond O's, but they have something else added to the end. Esters have an O added to the end. Many times esters are substances that give certain fruits their smell, like bananas or strawberries or pineapple. These are all esters. So let's look at an example of an ester. And to name an ester, just like the last grouping, we're going to have a special name to it. And we're going to put the word acetate at the end. So let's look at an example of an ester. How about this one? CH3, C double bond O, and maybe I'll try to highlight it a little bit better. CH2, CH2, CH3. So we have this picture. We can see the ester group kind of right here. This is this carbon. I should actually probably include this carbon with it, because we have to have that. Then this part is kind of like PROP, making sure I'm spelling it correctly, like a propyl group. And this, even though I'm counting it twice, you might think, is an ethanoate group. So let's think of what we would call it. Well, there's several names for this particular one. I happen to choose an example that could be called propyl ethanoate, or to be consistent with the name of an ester, with the name acetate, we would call it propyl acetate. Again, sometimes that is called propyl ethanoate. So enoate is another name for an ester, and sometimes acetate is, in this case, for this example. So that is a little bit of a very brief overview of different functional groups. I think there are 7 of them that you need to be familiar with. And in this process, you can enhance your knowledge and vocabulary of organic compounds by adding these particular functional groups that attach to the parent chain to give a variety of different names. Most of the time, the opportunity that we have in the AP class or the AP exam is really to use information about organic compounds to solve other problems. So there isn't a whole lot of working with these more complex reactions. So as far as we need to do, we need to just focus on the nomenclature, how to use it, and maybe a little bit of writing some of the compounds. And we'll do a little bit of that as we prepare for the AP exam.